Hello and welcome again to today's class. My name is Teacher Mary. Today we are going to learn about software development and computer programming concept. And the first thing which you need to ask ourselves, why should you learn programming? Programming lets us communicate with computers and create software that shapes the world. Without it, no apps, games, or website would exist. The biggest question, then why are programming languages that important in computing? Before we look at how they're important in computing, there are certain things which you must know, and these are known as the terminologies, or a few concepts that are used in programming. One of the concepts is programming itself. This can be defined as writing step by step instructions to tell the computer what to do. The next concept is programming languages. This is a formal language that is used to write codes that computers can understand. What you'll have to know is that there are very many programming languages, and it actually depends on what you want to do. The next terminology is a source code. These are human readable instructions written by a programmer before being compiled with a computer. Okay, you realize that a source code depends on a particular programming language. And the next terminology is a syntax. This can be defined as a set of rules that defines how code must be written correctly in a particular language. When we say syntax is a rule can be as simple as do not use square brackets, do not use comma where you're supposed to use full stop. What you have to know is that each and every, let me see, word or character has a meaning. And if you're supposed to use a full stop and you go ahead and use a full colon, we ought to say in programming is that you've committed a syntax error. And your code will never run until you correct that particular error. Another concept is actually a compiler. And what is a compiler? A compiler can be defined as a software that translates high level language into machine language before the program actually runs. In other words, a compiler translates it into whatever you've written into the language that only computers can understand. And notice that language only zeros and ones. The next terminology is actually an interpreter. An interpreter executes code line by line without compiling it first. You'll realize when you're building certain programs using a particular language, you actually not use a compiler, but instead you use what is known as an interpreter. The next terminology is an assembler. An assembler converts assembly language instructions into machine code. We'll look bit by bit at what exactly is an assembly language. Then the last bit of it is a machine code. Like I said, a machine code is a binary instruction that is directly understood by the computer or the CPU for that matter. And like I said initially, machine code is normally in the form of zeros and ones. One other thing that we need not to forget is an IDE. You realize that when you want to write a particular program or a particular code using a particular programming language, Some of them do not come like a single compiler. It comes with a set of other tools that your program will need. And for that matter, an integrated development environment is a software application that provides tools for writing, testing, and debugging code all in one place. An example of an IDE, the one that we commonly use, is NetBeans. We have NetBeans. You can either decide to use Visual Studio. You can decide to use another idea. It's escaping my mind. But NetBeans is so common. Oh, yeah, there's another one known as Eclipse. Yeah, I know recently. Is it Spain? It has experienced eclipse, but the eclipse I mean is not shadowing of either the sun or the moon or the earth, but it is a particular software that contains almost each and every tool that you're using for your programming. Then we have another common term is known as SDLC. In full, it's software development lifecycle. This is a structured program, I beg your pardon, this is a structured process outlining the steps to develop a software from the initial idea through deployment and finally finishing with maintenance. So actually the stages are summarized here, and this is similar like you want to write a particular program. Let's say you've been instructed to write a computer program that calculates the area of a triangle. And don't you know is a triangle to get its area is half, half base times height. So the first thing which you actually need to do is to plan. How is your code going to run? And when you talk of planning, after planning, there's analysis and actually designing it. Designing it, you know how it will start, how it will flow, and actually how it will end. So after analysis and designing, you go to the next step, which is implementation and testing. When you say implementation, this is actually the actual building, or let me say coding of your software. So now this is now involves writing the source code, compiling and you test if there's a certain error and you debug. When I talk of debugging, is actually removing the errors. And you read the code, debug the errors, and verify that the software or the program is working properly. Then we have deployment and maintenance. What you have to know about deployment is actually now it's like you installing or making the program run in a certain computer. Now that you've removed all the errors and everything, this ensures that the users can continuously use the particular software or the program that you built without any queries. And maintenance ensures that the software, the program keeps on improving into a better version. Okay, let's look at evolution of programming languages. One thing you have to know about evolution of programming languages, it goes hand in hand with the evolution of computers. You can remember how the early computers used to look like. Actually, when computers were developed initially, programmers had a big task to do. So, if you want to understand the evolution of programming languages better, it has to go hand in hand with evolution of computers. So, early languages were machine specific and extremely difficult to use. Over the time, new generation of programming languages made coding easier, more powerful, and accessible to more people. Then let's go to the next generation. Here we have the first and second generation. First generation, now this is machine language in binary code, like we said. Binary code is in form of zeros and one. It is directly executed by the CPU. The fastest execution, but extremely difficult to write and understand. You know why it's difficult to write and understand? Because this is actually a series of zeros and one. For example, you have like 10 zeros and one, and it's like 110011 up to 10, and you're like, now what does this one mean? To you as a human, it will be very hard to decode what this one is all about, but the computer really understand. Then from the first generation we go now to the second generation, whereby here we have the assembly language. And assembly language uses mnemonics. Mnemonics is more like abbreviations. An example of an assembly language, you have MOV, which stands for move. Then we have add, and then we have remove, and all that. But what you have now is just basically mnemonics, and those mnemonics are simple instructions. Compared to binary, these ones are readable but still hardware specific. It requires an assembler to convert it into machine language. Now let's go to the next generation of machine languages. So in this case, we have the third generation languages. Examples, yeah, in this case, you have Fortran. I'm sorry, my slide is saying C and then there's written Java, but C is a programming language, that's a typo. Sorry for that. Then we have Java, we have Ada, we have Perl, we have PHP, and the list is endless. So, third generation languages introduced human readable syntax, making coding more accessible. Example include, yeah, just the examples I've given of programming languages. And these languages are portable across machines and require a compiler or an interpreter to run it from now a language that you can understand to a language that the computer can understand. To the next generation, we have the fourth and fifth generation. For this matter, now we have uh, SQL. We have SQL and other query languages and reporting. So for this case, fourth generation language include SQL for database and report languages. And actually, now you'll realize that careers like data science is now very much marketable. And for data science, we deal with a lot of report writing, analyzing data, and all that. And that's where technology is heading towards. So some of the programming languages used here are mainly used in querying data and getting all. If you want to get a piece of data from a large data, or even that particular data to be analyzed, so the languages are in this particular generation. So the next bit is now going to look into more of these languages that we've talked about. And the first one is actually understanding low level programming. When you talk of low level programming, now this one, okay, before I explain more about low level, we have low level and high level languages. Low level is the one that basically is being understood by the machines, that is in form of zeros and one. So low level languages interact directly with the computer's hardware, enabling direct memory manipulation and processor control. Learning how these languages work helps us to truly understand how computers process instructions to their core. And like I told you, these are the low level languages. Let it not give you pressure because it's not for you actually. It's for the computer. The next bit of it, you're going to look at um, simulating low level instructions. And for the first one, we have no, this one is what do you call it? It's escaping my mind, and I've just mentioned it. The assembly language. Actually, like I said, assembly language is an improved version of machine language. But this one is now, it has basic English that you can understand. For example, we have an English word like load. That one you can really understand. This one loads value 5 into a register 1. You can remember registers, you did them in computers in the CPU. And we said the CPUs have registers which are small bit very of very fast memory. Thereby, it makes it's used when the CPU is processing data. The next instruction that we can give we can see there is add store. So it's more English like and it's better compared to the previous version of machine language. Now this one is it's basic English and at least you can understand. The next bit of it, we are going to look at programming paradigms. Now, when we talk of paradigms, now these are like different categories of programming languages. And the first one we have imperative programming languages. This one ensures that commands change program state step by step, giving direct control over operations. In simple words, I give an example of a computer program that calculates the area of a triangle. So when you talk of an imperative programming language, now this one works steps by step. In other words, kuna mahali unaanzia. Where do you start? From that start, what is next? Like the example that I just gave, like a computer program that calculates the area of a triangle. What you have to know is that before the program works, before you get the area of a triangle, there are certain things that you have to get. You have to get the base and the height. Once you have these two components, then getting the area of a triangle is much easier. So if it's an paradigm, you're like, we're going to instruct get the height, get the base. Then we say area of a triangle is half base times height. On to the next paradigm, we have procedural. Programs in this case are executed using procedures or functions for modularity and reuse. When we talk about a function or a procedure, these are like uh, you're creating a mini program within a program. Yani program ndogo kwa program kubwa. Such that this program ndogo, they perform simple tasks and they're within the main program. And these are an example of this one is a language like C. It uses procedural paradigm. Then we have object oriented. Object oriented mainly organizes um, codes into objects with data and methods. I know this one is a bit tricky, somebody is asking. So, object, how do you go about it? But I've just explained this an entire program. It can be like a whole topic by itself. So the next bit of it is just looking at the paradigms one by one. Then we have imperative, we have procedural, and you have object oriented. Uh, this other part, I want us to take a look at this particular video, and
Become
it's
an
going
essential
to
skill. Whether you want to build a website,
give
create
us
an
more
app,
view
or
on what
simply
you need to
understand
do.
how software works,
Let's
learning to
listen to this.
program is the first step. In this video, we'll cover the basics of programming, giving you the foundation you need to get started. So, let's dive in. First, let's clarify what programming is and how it differs from coding. The terms programming and coding are often used interchangeably, but there are subtle differences between them. Programming refers to the comprehensive process of creating software. It encompasses everything from planning and designing to coding and testing. Programmers are responsible for conceptualizing the logic of a program, designing its structure, and solving complex problems. They focus on creating algorithms and workflows that guide the software's behavior and ensure it meets the specified requirements. Coding, on the other hand, is a specific part of the programming process. It involves writing the actual lines of code using a programming language to implement the design and functionality envisioned by the programmer. Coders translate the logical solutions and algorithms into a syntax that the computer can execute. In essence, programming is like constructing a building where you start with an architectural plan and oversee the entire construction process. Coding is akin to laying the bricks according to the blueprint. Both are crucial, but programming encompasses a broader scope that includes coding along with other essential tasks like debugging, testing, and optimization. Now, let's see why you should learn to program. Learning programming is an invaluable skill in today's world. It not only opens up a wide range of career opportunities in various industries, such as software development, data analysis, and cybersecurity, but also enhances problem-solving and logical thinking abilities. Programming empowers individuals to create their own applications, automate tasks, and bring innovative ideas to life. Additionally, understanding programming fosters a deeper comprehension of how technology works, making one more adept at navigating and leveraging digital tools in everyday life. Whether you're looking to advance your career, develop new skills, or simply challenge yourself intellectually, learning programming offers numerous benefits and can be a highly rewarding endeavor. Next, let's explore some basic concepts that are common across all programming languages. As you may know, there are many programming languages, each designed for various purposes and applications. Some of the most commonly used ones are Java, C++, Python, JavaScript, and C#. While each language has its own unique syntax and rules, they all share several fundamental concepts. These include variables, loops, conditionals, functions, and classes, among others. Let's take a closer look at these key concepts. Variables are basic elements in programming that store data values which can be used and manipulated throughout a program. They act as placeholders or containers for information, such as numbers, text, or other data types. By assigning a name to a variable, programmers can easily reference and update the stored value as needed. For example, in many programming languages, you might declare a variable with a statement like age equals 25, which assigns the value 25 to the variable named age. This makes it easy to manage and use data dynamically within a program. Some languages also require the programmer to explicitly set the data type of a variable. In this case, that would be integer. So in languages like Java or C++, you would write int, age equals 25. Depending on the data type, you might also want to perform other operations on variables such as incrementation and negation. For example, in Python, we can write age equals age plus 5, which would increase the value of the variable age by 5. Next, we have loops. Loops are essential structures in programming that allow for the repeated execution of a block of code as long as a specified condition is met. They are used to automate repetitive tasks, making code more efficient and easier to manage. The two most common types of loops are the for loop, which iterates a set number of times, and the while loop, which continues until a certain condition is no longer true. For example, in Python, a loop might look like this: for I, in range 5, print I, which would print the numbers 0 through 4. Loops help in managing tasks that require iteration, such as processing items in a list or performing actions until a particular state is achieved. Up next, we have conditionals. Conditionals are a fundamental concept in programming that allow code to make decisions based on specific conditions. They enable a program to execute certain blocks of code only if a given condition is true. The most common conditional statements are if, else if, and else. For example, in Python, an if statement might look like this. If age greater than or equal to 18, print, you are an adult. This code checks if the variable age is 18 or greater, and if so, it executes the print statement. Conditionals are crucial for creating dynamic and responsive programs that can handle different scenarios and inputs effectively. Next, we have functions. Functions are reusable blocks of code in programming that perform specific tasks or calculations. They allow programmers to organize code into modular, manageable sections, promoting code reuse and reducing redundancy. A function typically includes a name, parameters, and a body of code that executes when the function is called. For example, in Python, a simple function might look like this: defgreet, name, print hello plus name. This function, greet, takes a parameter name and prints a greeting. By using functions, programmers can write cleaner, more efficient code that is easier to test, debug, and maintain. And lastly, let's take a look at classes. Classes are a fundamental concept in object-oriented programming that allow programmers to create custom data types by bundling related properties and methods into a single blueprint. A class defines the structure and behavior of objects which are instances of the class. For example, in Python, a class for a car might look like this. This class includes attributes like make and model and a method to display information. An instance of this class could be created with my car equals car, Toyota, Camry. By using classes, programmers can model real-world entities and their interactions, promoting code reuse and organization. It's become an essential skill. Whether you want to build a website, create an app, or simply understand how software works, learning to program is the first step. In this video, we'll cover the basics of programming, giving you the foundation you need to get started. So let's dive in. First, let's clarify what programming is and how it differs from coding. The terms programming and coding are often used interchangeably, but there are subtle differences between them. Programming refers to the comprehensive process of creating software. It encompasses everything from planning and designing to coding and testing. Programmers are responsible for conceptualizing the logic of a program, designing its structure, and solving complex problems. They focus on creating algorithms and workflows that guide the software's behavior and ensure it meets the specified requirements. Coding, on the other hand, is a specific part of the programming process. It involves writing the actual lines of code using a programming language to implement the design and functionality envisioned by the programmer. Coders translate the logical solutions and algorithms into a syntax that the computer can execute. In essence, programming is like constructing a building where you start with an architectural plan and oversee the entire construction process. Coding is akin to laying the bricks according to the blueprint. Both are crucial, but programming encompasses a broader scope that includes coding along with other essential tasks like debugging, testing, and optimization.
Thank you for that. Now, is there anything that you got from that particular video? If there is, or there's a question, you can put it in the comment section. For now, it's bye, adios, and thank you for listening. Kwaheri.